Dos, tres, cuatro.
Hi everyone, welcome to our unit on conics. We're going to start with 8.1, which is on linear equations. So it's a review from Math 10. There's not too many extensions, but if you think back to Math 10, I'm not sure the level of detail that you go into, but we're going to take a look at midpoint, the distance formula, and how to find the distance between two lines, and a review of slope, and looking at things in the form of y equals mx plus b, general form, also known as standard form, and point slope form. So we have those things to review and to take a look at, and hopefully some of it will sound familiar from what you've learned in the past. So let's just do a refresher. So as a warm-up right here, we could say something like this. If you have the point -4, -1, and the point 6, 5, let's plot those right now. So at point A, -4, -1, and with 0.65, and let's join those two and let's create a line segment. So the question is saying, based off of something like this, can you find the distance between points A and B? And to do that, we know that it wouldn't be something that we could find instantaneously just by looking at it, because it's not a vertical line and it's not a horizontal line, but rather it's this diagonal line. And thinking back to what you could recall is the easiest way to construct this without using the distance formula exactly, because we're going to derive that, is you could create a right-angled triangle. So let's do this right now. Let's drop a line down here, and let's drop a line over here, and let's put in a right-angled triangle. So we have something that we'd be able to work with to be able to see the height of the triangle and the length of the triangle. And we can easily count by looking at the y values. If we're at -1 and we're going up to 5, we could say that this is going to be a distance of 6 units. And moving horizontally, we're going from -4 to +6, so this is a distance of 10 units. And so if you have something like that and they want to find the distance of our points, well, we know that we could say a squared plus b squared equals c squared. And if we can find out what c is, finding our hypotenuse, we'll be able to find out the distance between these 2 points. So let's take a look at what we could say. 6 squared plus 10 squared is going to equal c squared. So 36 plus 100 is going to equal c squared. And then based off of that, we can put everything together. We could say 136 is equal to c squared. So if we want to find out just what c is, we could square root both sides, and we could say that the square root of 136 is going to be equal to c. Now, if you think about something like the number 136, if you were to break that down doing some form of a factor tree or something like that, you could say, okay, well, that's going to go in, well, it divides by 2 for sure, and I'd be left with the number 68. And then based off of that, that could go to become 2 and 34, and that could become 2 and 17. So you get these different factors. And from there, you could say, I can leave this in exact form. I could say, well, it's the square root of 136 units. Or if I wanted to create a mixed radical, I could take out a 2 because there's a pair of 2's. And so you could say this is the square root of 136 units squared. Or as a mixed radical, because I could factor out a 2, I could say it's 2 root, and then these guys stay inside, 2 root 34 units squared. Both are acceptable ways of being able to say something like that. Now, if I wanted to average this out, so for part B, it's saying what's the midpoint for A and B? And so here we had point A and here we have point B. Well, we could do the same sort of thing where we can take a look at this 10. So that's our horizontal distance over. And if you split that in half, you would be going over 5. And if you look that you would be having a vertical distance of 6, you could split that in half and you could go up 3. So from point A right here, if I travel 1, 2, 3, 4, 5 units, 5 units right, and I go up 3, 1, 2, 3, means I probably didn't draw my line segment very well. But taking a look at that, I would have the point right here that would be at 1, 2. And if you think about that, that does look like that would split A and B right in half, and hopefully it does. And so then we could say our midpoint here will be the point 1, 2. And then finally, they want to look at the slope. And so if we want to see something in terms of the slope, let's think about our rise and our run. We're going up and to the right, and we'll remember that going up and to the right is a positive slope. And so because of that, our rise over run could be something like this. And this, I'll give the part of the formula right away because we talked so much about saying rise over run in the past. And so in this case, we're going to rise 6 and we're going to run 10. And then in lowest terms, that would be going up at a slope of 3 over 5. So in terms of what we could say for an equation of this line, now taking a look at it, it doesn't necessarily look like it crosses the y-axis. There's not a y-intercept that's at a really clear point. So this could be potentially a little bit messy, but what we could say is this. In the form y equals mx plus b, let's just do a quick refresher. We know that b is representing the y-intercept, and we know that m is going to represent our slope. And our slope here is 3/5, so we could say y equals 3 over 5x plus b. And we don't know what the b value is, but we do know several characteristics about the line segment. And one of the things that we can use to our advantage is we know several points that the line segment crosses through. And so it doesn't matter what point we pick. I'll pick the point 6, 5, and but I could have easily picked the point -4, -1, or we could have picked the point 1, 2, but I'll pick the point 6, 5. And what we could do is we can sub in 6, 5 for x and y, and we can find b based off of that. So going up over here, I'm going to put in a 5 for y, and we'll say 5 equals 3/5 times 6 plus the letter b. Make sure my 6 and my b look different from each other. Okay, and so from here, we want to be able to isolate for b. And there's a few ways we could take a look at the algebra with this, but I'll say 5 equals 18 over 5 plus b. For me, what I'll do is I'll say I want to get rid of that 5 as a denominator. So I'm going to go times 5, times 5, times 5. We're going to times both sides by 5 and distribute it on the right side. And what that does is it gets rid of this 5 down here. And then we could say 25 equals 18 plus 5b. Subtract 18 onto both sides. And we get 7 equals 5b, meaning that b will be equal to 7 over 5. So to write our full-on y equals mx plus b, we would have y equals 3/5 x plus 7 over 5. Now 7 over 5 is equivalent to saying 1.4 is a decimal. And so if you go back up here and you take a look at this, hopefully it looks like it would be something where it could be at 1.4. I don't think we drew this line very well, but if we let's redraw this, and we take a look at what our line segment could be. So we go right here. Like that. That looks a whole lot better. Then I would say that definitely would cross above 1, below 2, and something like 1.4 seems to make a whole lot of sense. All right, so that's our little review for bits of that. Let's look at the distance formula in a little bit more detail. So it says using 2 points, can we create the distance formula, and what would we have for something like that? Okay, so let's put a point right here. We'll work in quadrant 1, and we'll say that this is point 1, and I'm going to travel, let's do this. I'm going to travel over 3 units, 1, 2, 3, and up 1, 2, 3, and up 4 units. And based off of that, I'm going to create our line segment of what we're trying to find right here. Okay, and if we call our point at the bottom here, point 1, then we can label that and we could say this would be x1, comma, y1. And up here, we'll say that this point here is going to be x2, comma, y2. And we want to find the distance between those 2 points. Okay, so we've created our right angle triangle because we know that Pythagoras can help us find out the length between them. But I want you to think about how you could find out this a little bit more theoretically. So think about the height. If you have this height here, and we have a point up here, a y value of y2 up here, and this point down here is a height of y1, then the distance from your height, your vertical distance, would be y2 subtract y1. And if that seems kind of strange, we could use our the actual points on where we've plotted, and you could think about this. Well, our first point here is the coordinate 1, 2, and the point up here is the point 4, 6. And so if you think about the height, you had a height with a bottom distance of 2 and a top distance of 6. And to find out how far they are apart from each other, you could say it's 6 minus 2. But instead of saying 6 minus 2, you could say it's y2 minus y1. And that would let us know something for any situation to be able to find the vertical distance between 2 points. Now to find the horizontal distance, let's look at this. I could take my x2 value and I could say my horizontal distance over here is going to be x2 subtract x1. And again, let's look at the numbers that we have for this. So this had an x value of 4. This has an x value of 1. We know that they're 3 apart from each other. And you could say 4 subtract 1 will give you the horizontal distance of 3 units. And theoretically, that would mean that we could say something like x2 minus x1 will always give us the horizontal distance between 2 points. So if we have something like that and we want to start to be able to build and expand a formula, think about what would happen using Pythagoras. And if we said something like a squared plus b squared equals c squared. Well, in terms of looking at how far you would travel over, you could say it could be something like the horizontal distance would be x2 minus x1 squared plus the vertical distance of y2 minus y1 squared, and that would all equal c squared. But we don't want to find out c squared to find out the length of the line. We want to find out just c, so we need to square root both sides. And so if we square root both sides, we would now have our distance isolated. And so instead of saying c equals this for the distance formula, we could say something like d. And if we say d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, we now have our distance formula, and we can apply that without having to create it every single time. So let's fill that exact same thing into this box right here. So distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now you might be wondering why we chose these particular points to work with for when creating the distance formula, and I thought about, well, what's our most famous Pythagorean triplet? And it's a 3, 4, 5 triangle, so we were able to use some nice clean integer numbers to see if this would work. And we know that if you worked out these numbers, and I'll let you do that on your own, you'd be able to say, well, if my horizontal distance is 3, my vertical distance is 4, I know that my diagonal, my c value, will be 5 because it's a 3, 4, 5 triangle. Now, the midpoint is even easier to create. In fact, I'll probably just talk about it more than anything else. If you think back to the last example that we did in our warm-up, we averaged the x values and we averaged the y values. And so think about what you need to do to be able to find the average of something. You're going to add them up together. So we're going to add up our x values together. So x1 plus x2, and then we're going to divide it by 2, and that finds the average of x. And if you want to find out the average of y, you could add up your two y values, divide it by 2, and this would give us our midpoint every single time. Just as a review in terms of the three types of ways to be able to write equations of lines. So I would say probably the most common is slope-intercept form, also known as y equals mx plus b. If you have something like called general form, sometimes you might see this as standard form as well. I've seen this written in two different ways. So actually, I'll give you both ways. So it's pretty common to see something in the form of ax plus by equals c. But I've also seen us write it as ax plus by minus c equals 0. So if you want to write it in either form, I'm okay. I would say, why don't... some people are probably going to ask this in class, say, well, which one do you want? Why don't we stick with this first one right here? And if you want, I've even seen ax plus by plus c equals 0. So you could say something like that too, but we'll say this will be our way of saying general form. Here's our way of saying slope-intercept form. And then finally, we have point-slope form. And point-slope form we use from time to time as well, and that is y minus y1 equals m bracket x minus x1, and we use that whenever we're given the slope and we're given a single point, and you can find out some information about that almost instantly. Okay, so we've got a couple questions here where I would say probably you're feeling pretty confident. You could pause the video, you have your formulas available to you, and you can work on a couple of these examples. So I'll start to go through them, but why don't you give it a try and pause the video first and see what you could come up with. So to find the distance between these 2 points here, what I usually do is I would label this as x1, y1, that's my first point, x2, y2, that's my second point. And then we could write this out and you could say d equals the square root of, and then we know that we're going to subtract the x's from each other. So we could say x2 minus x1 squared plus y2 y2 minus y1 squared, like that. Okay, so then we would get something that would say 7 squared, which would give us 49, negative 3 squared, which would give us positive 9, and then our total distance is going to be the square root of 58 units. So you could say something like that. That's a good way of being able to leave it. If you want to try and see if you can turn that into a mixed radical, you would get 2 and 29. So I don't think you could do anything too much more, and we probably have to just leave it like that. To find the midpoint right here for example number 2, so we know midpoint could just equal something like averaging our x's and averaging our y's. So let's see what we could have with that. Again, x1, y1, x2, y2. You add up the x's and you could say 7 plus negative 1 over 2. And then for your y values, you could have negative 2 plus 4 divided by 2. And let's see if we can clean that up. We would get 6 over 2, so we could get something like 3 comma 2 over 2, which is 1, 3 comma 1, and that would be our midpoint right there. And then if we wanted to be able to find out one endpoint of a line segment for AB is 3, 4. And if the midpoint is negative 2, 3, they're saying what are the coordinates of point B. So for something like this, you might want to do a mini graph and just do a quick sketch to see what you could come up with. And that might be a good way just to visualize what you're looking for. So I'll do that in this case, but it's not necessary. So they're saying here, one endpoint is at 3, 4. That's point A right here. And they're saying at -2, 3. So somewhere right around here, -2, 3, that would be our midpoint. And so think about where you're going to be finding point B. So if this is A's one endpoint and you have your midpoint here, somewhere over here, this is going to be point B. And that would give us something where we could have M in the middle right there. So how would you approach this? We know the midpoint formula, and we could use that to our advantage. You could probably even just count things over if you want to be able to count things over. There's lots of ways to be able to think about it. So I'm going to do this just maybe almost by looking at it a little bit, but if you want to look at the algebra of it, we could do that as well. So think about the x values. If -2 is in the middle, and I've gone all the way over to 3. That means that I've traveled from -2 to 3, I've traveled 5 units to the right, which means that I would need to travel 5 units to the left to be able to get to B. So if I go 5 units to the left of -2, I would be at -7. Think of your up and down values, and probably I didn't put B in the best spot actually, because if you have a y value of 4, and then you have a midpoint that has a y value of 3, then it makes sense that your y value for B would be at +2. Sorry, you've gone from 4 to 3, which is a distance of 1. So then you go down 1 to get to 2, and you'd be right there. So probably I should have said B is going to be somewhere in this region over here. Now, if you wanted to use your midpoint formula, you could, but again, I think that's almost taking too much time to be able to do a question like that. Okay, our next example. Find the equation of a line, and it doesn't say, it says in slope-intercept form, with the point 2, -4, and with a slope of -2/3. So if you want, you could use point slope form to be able to put that in and then rearrange it. So definitely feel free to do that, and that's a very good method. Another way of doing it is similar to what we had done for our previous question, where we had mx plus b, and we said, well, if our slope is -2/3, and we know that we have a point on the line to -4, we could just sub that in and we could solve for b, and then we'll have that. So again, either method is good. So if I put in -4 equals -2/3, our x value is 2 when we do that, plus our b, and you could say -4 equals -4 over 3 plus b. You could times everything by 3. -12 would equal -4 plus 3b. Add 4 onto the other side, so you get -8 equals 3b divided by 3, and b is equal to -8 over 3. And so then you could say y equals -2/3 x minus 8 over 3, meaning we have a y-intercept of -8 over 3. So that's one method. Just below here, I'll quickly show you what it would look like if we used point slope form, and you may prefer that. So point slope form is useful in this case. So if you said y minus y1, our y1 value is -4, equals, and then you would have your slope, which we know is -2/3 of x minus x1. And our x1 value is, in this case, 2. So x minus x1, like that. And based off of this, we would just have to then say we could distribute this, and we could say y plus 4 equals -2/3 x plus 4 over 3. And then we could subtract 4 onto the other side. and then you'd want to get some sort of common fraction for your y-intercept right here. You could say y equals negative 2/3 x, put this over 1 times by 3 times by 3, and you'd get 4 minus 12, which would be negative 8 over 3. And sure enough, we get the exact same answer. So both methods are good methods to be able to do for this. Okay, final example is find the equation of the line going through negative 2, 5 and 4, 3 in slope-intercept form. So there's just really one extra step to this style of question than what we've had from the previous question. We need to be able to find out the slope. And so we've said that slope is equal to rise over run, but we should also say it's y2 minus y1. This is going to be familiar, over x2 minus x1. So that's your slope. You'll be given that formula for any quizzes or tests, but it's something that I'm pretty sure that you guys know already from in the past. So here's x1, y1, x2, y2. And then to be able to find out our slope, in this particular case, we could say y2 minus y1 over x2 minus x1. And we would get negative 2 over 6, which can reduce to negative 1/3. So then from there, we can say y equals negative 1/3 x plus b. I'm going to stick with my subbing in of a point method, the first method that we did from the previous example. You could pick either point. You could pick negative 2, 5, or you could pick 4, 3. I like sticking with positive numbers, so I'll pick 4, 3. And we'll say, let's substitute in 4, 3 for x and y, and then solve for the b value. So instead of writing y, I could write 3, and then instead of writing x, I could write 4. And we would get something where we could solve for b pretty quickly. Let's times both sides by 3, times 3, times 3, times 3. And we would get 9 equals negative 4 plus 3b. And then if we add 4 onto the other side, and we continue up here, we have 13 equals 3b. So then b would be equal to 13 over 3. And we could say y equals negative 1/3 plus, negative 1/3 x plus 13 over 3. And that'd be a great solution. Okay, we could talk in class to see if we edit down the homework, but right now, here's some great questions to be able to practice, and that's a review of linear equations.